Hi everyone. That pronunciation was perfect. Dan Poltawski, I'm systems architect at the networking people. We've been using Loki for log aggregation for our network devices and wider than that for about the last year or so. It's quite different to other logging solutions, so I'm just giving a kind of quick overview and run through of it and its advantages compared to other solutions. So Loki is an open source project started by Grafana Labs, who make the Grafana dashboard. I may start saying Grafana here because it's confusing the Grafana, the dashboard, and Grafana, the company. One of the sort of driving goals behind it was to make it a kind of cost-effective and easy-to-operate solution. It's open source, but it does also have, and we self-host it ourselves, but there's also a SaaS version of it. It's got like a powerful query language, which I'll give a bit of a info about, and it integrates well with the Prometheus ecosystem. In fact, its tagline is like Prometheus, but for logs. So what sets Loki apart from the other logging solutions? The primary difference is that Loki only indexes on the metadata associated with the log line and the like timestamp. So in this kind of example I tried to show on the slide, we've got the IP address and the host name and the timestamp. That is indexed, but the actual content of the log is not indexed. That dramatically reduces the resource requirements for Loki. And in addition to that, the log content is stored compressed. So the kind of the classic counter example is Elasticsearch-based solutions. The example I've put there is 40 gigs worth of log data with Elasticsearch that ends up ballooning in with the index included to 100 gigs worth of data, whereas in Loki it's 9 gigs. But there's a reason why Elasticsearch and other solutions and stuff index on that kind of log content of the log, and that's because when you need to find the needle in the haystack, how do you look it up? So Loki's solution to this is to do distributed grep, is the best way of describing it. It splits the work up into lots of little chunks and throws compute resource at it to get to it. So filtering and parsing happens at query time rather than at log ingestion time. That also has some advantages in that you don't need to think too much about the content of the log data that you're indexing at the time when it's coming in, because that happens as it's going out. And Grafana get very good speeds with that. So a quick kind of run through of the architecture, starting on the slide from the left to the right. We've got sort of three kind of components of the whole infrastructure. There's getting the logs in, then in the middle the processing, and then on the right hand side the querying. So on the left hand side we're taking syslog data from our various network devices of various vendors. We process it initially through our syslogd. That's kind of a recommendation of the Loki team. They suggest using our syslog or syslog-ng because those kind of projects are much more battle hardened to dealing with the kind of weird and wonderful ways that syslog gets sent. But Promtail is the sort of companion application to Loki. It's also a Grafana Labs project, and that can receive syslog data and then send it on to Loki. Loki itself is a Golang based application. It needs some storage. There's multiple different storage providers available. We just use the file system storage, but there's a lot of cloud block storage type options. And Loki provides a HTTP-based API for sort of getting the logs in and for querying that data. So then on the right-hand side, there's kind of two major ways of accessing the log data. There's the Grafana dashboard, which there's ways of querying and filtering, etc. And then there's also a command line application, LogCLI, and there's obviously also an API for it as well. I'll just skip through the keys because I've covered them. So how do you query the data? There's a language which they've created. It's inspired by the Prometheus PromQL called LogQL. And the basics of how you do a query is you select the kind of log labels that you want to have a look at. So in this case, an IP address, and then you can apply filtering on top of that. So in this example, we've got searching for SSH, and we match the log lines. So that's the kind of basic example. But the sort of real power comes from it by using one of the parsers. One of the parsers is the pattern parser. Here we're doing a pattern match on the log line. So I'm searching for failed password for the username, the blank username from source IP. And then we extract that at query time, and then we can filter on it. So then on the next line, we're filtering on the source IP, and then I'm just printing that out to kind of demonstrate it. Another parser is like the log format parser. In this example, we've got a line from a Fortinet device. It's a kind of classic key value situation where it's, the key equals the value. With this parser, you just kind of pass it through, and then you can start filtering on it. Was a demonstration there. And there are more parsers. There's a JSON parser, there's a regular expression parser, and there's lots of other LogQL things that you can do. I just wanted to point out one LogQL function, which is the IP address matcher. That obviously useful for network devices. It allows you to match on an IP address, CIDR notation, or range notation. The other thing to say is that the Grafana dashboard has a query builder to do it in a sort of GUI way. That's evolving quite rapidly at the moment. It's kind of a new functionality, but yeah, you don't need to know all the syntax to operate it. So then the sort of real power magic feature of Loki is then the ability to turn from that data metric queries, so to get values from it. So in this case, we're searching for a failed password log line. We're extracting the username and the source IP, and then at the bottom we sort of then we count those over a 12-hour period, and then we sum on that and get the sort of output at the bottom. And it's with that the real power with Loki comes, because you can then graph on that, you can create alerts based on it, and yeah, that's Loki's superpower really. So to summarize, Loki takes a different approach to indexing data. It's easier to operate, costs less to operate. It's still quite powerful with this kind of mechanism. And yeah, it's a good one to be aware of. Any questions?
Thank you, Dan. Great talk. Let's see. Any questions in the room? Dave, any questions?
I've not had any questions, but I've got my own questions.
Please.
So how would you say this compares to some of the more SIEM style logging platforms? Is this something that you can use to detect network intrusion or nefarious patterns, or is it something that's just a good way to gather general data?
So there's not like kind of AI intelligence kind of things bundled onto it at the moment, and it's a bit more of a black and white type thing. But I think one of the things that you can do, and is something that we're experimenting with, is kind of like normal log levels of certain types. So you can sort of you could create like a graph of the rate of certain expected types of rates of messages, and then use that to kind of do that kind of thing.
So if you can come up with a decent definition of what normal looks like, it
Mm-hmm.
can tell you when it isn't.
Yeah.
Fair.
Yeah.
Thank you very much.
Any other questions? No? Then we'll thank you very much, Dan.
Thank you.